This is from 7.1 and 7.2 in your book, Exponential Growth and Decay. The main formula that helps you do all of these problems is this. It is y equals, for anything in this function family of exponentials, it's y equals a times b to the x power. It's very simple. Anything for exponential growth and decay will follow that simple format. And so I'm going to tell you what each part means. You already know, x and y are those. You plot those on the x-y axis. So a is your start value, your initial value, and graphically you'll see that whatever that number is, it ends up being also your y-intercept. But that's your initial value, or y-intercept. That's how much you start with. For example, how much money you start with. This number b is called your multiplication factor. It's what you multiply by each time. So if you want to double something, if that's how your growth works, that would be a 2. So this is the multiplication factor. That's how much it's growing by. So that, for example, if it were 1.20, that's for a problem where something grows 20% each time. If it were like 2, that means it doubles each time. If it were like 1.10, that's your growth factor. It grows 10%. If it were 3, what would that mean? Instead of doubles, it triples. 3 would be it triples. So that's for growth. If it's a number smaller than 1, like 0.5, what's happening every time? It's not growth now, it's decay. So what does 0.5 do? It cuts it, it cuts it in half each time. This cuts in half. 0.5 would cut in half. Now, interesting enough, 0.60 that gives you 60% of what you started with. That's a decrease of 40%. If it were 0.75, what's that? A decrease of. If you only have 75% left over, you just decreased by what percent? 25%. Yep. So whatever that number, those are all the different, those are just examples of what B could be. So this is the amount of money you start with. This is what you multiply by every time. And this X is the number of times that you do it. Like if you're working at Google for 30 days in that example, you would raise it to the 30th power. This is the number of times you multiply by. And that makes sense, right? Because that's what an exponent does. So you take this initial amount, you multiply it by something a certain number of times, and everything for exponential works like that. So if we were to take the example to see how much we would make on the 30th day working at Google if we started with 1 penny. So for example, the amount that we would make would be, if we started with 1 penny and we multiplied, you're doubling something, so you multiply times 2, how many times? Raised to the 30 power. That's how many pennies you would make. So what is 2 to the 30th power? This is the power of exponential growth. How many pennies are you making on the 30th day? 2 raised to the 30th power is?
Why is it 1?
You started with 1 penny in the Google example, and then you doubled it. You multiply by 2, so the next day on day 2 you're making 2 cents. Then you're making 4 cents. What's 2 raised to the 30th power? 10, 7, 3, 7, 4, 1, 8, 2, 4. So that's how many pennies we make. So in dollars, we would just divide by 100, right? So that many dollars. So let's put some commas in here. So how much are we making on the 30th day? That's quite a bit more than normally you would only making $1,000 on that day, right? In the other example. So exponential growth is really powerful. Now the last thing I'll say is that because I just want it in your notes that yeah, 10 million. So the graph of growth looks like this, just generally speaking. So you have a start value like this much money, like it might be 1 penny, whatever, and then it goes up exponential. That's the shape of exponential growth, and you extend it in this direction even though you don't really, in applications, you don't really use it in this quadrant. It's more or less start value and then it goes up. And the graph of decay looks like you start with some amount like this. I mean, it could be lower, whatever, it doesn't matter. It could be low, like here, you start with some amount and then you decay exponentially. Do you ever get nothing? If you take something and you keep cutting it in half every time, you're never going to get nothing. So this line right here is called the asymptote. The x-axis is, you're never going to touch it. That's your asymptote with exponential growth and decay. And we do want to extend it in this direction, but we don't usually care about that quadrant with applications. We use this. Start amount, that's A. This is the value of A. This is A, your initial amount. You either grow by a certain amount and it goes up quickly, as you saw in the example, or it goes down steeply and then levels out. So that's the gist. This will go a long way. Right here is pretty much the main thing you need to use. You just got to figure out different ways to use it, different forms, different applications, but that's the gist.